My name is Alexis Caldwell, and I will be discussing non-deterministic pushdown acceptors, also referred to as NPDAs. So NPDA can be defined by the following subtuple, where Q is a finite set of internal states, sigma is the input alphabet, gamma is the stack alphabet, delta is the transition function, Q sub 0 is the initial state, Z is the stack start symbol, and F is a set of final states. So today we're going to be drawing out NPDA for the following language. So let's look at this language and see what type of strings are accepted by the language. So as we can see, we have to have 3 A's followed by any number of B's followed by any number of C's. We see that the number of B's has to be equal to the number of C's. But also n is greater than or equal to 0, meaning that we can have no B's and no C's. So since we know that we can have no B's and no C's, we know that the string A is accepted in the language. So let's start drawing our NPDA. We're going to start at state Q0. And that's our initial state. We know that we have to have 3 A's. The string has to begin with 3 A's. So we're at Q0, we read in the A. Z, our start symbol is the only thing that's on the stack because we haven't pushed anything on yet. So when Z is at the top of the stack, we're just going to replace that with the Z, meaning that we're not going to change anything because we have a finite number of A's, so we know how many we're going to read in. So for the second A, we're going to do the same thing. Z is still at the top of the stack because we haven't pushed anything on. And we're just going to replace that with another Z. Ew. The numbers off. So for Q2, so we're going to read in our last A. And we're just going to repeat that again. Now we're at Q3. As we found before, the string of 3 A's is accepted in our language. So Q3 can be a final state. But we're not done. Now what if we want to read in B's? Well, if we want to read in B's, I'm going to read in a B. We're at Q3, we're going to read in a B. Z is at the top of our stack because we haven't pushed anything on. But now we're going to push something on the stack just to start counting Z's. So we're going to push on 0Z. And now we'll be at Q4. So now we're at state Q4. We don't know exactly how many B's we want to push on or how many B's we will have in our language or in our string. So we're going to create a loop. So when we add a B, when 0 is at the top of the stack, we're just going to replace that with another 0. That way all of the B's are accounted for. But now, what if you want to read in a C? Well, if you want to read in a C, going to take us to state Q5. C, 0 is going to be at the top of the stack. But we want to have the same number of C's as B's, so we're going to just remove a 0 every time we input a C with our lambda. So now we don't know how many B's we have on our stack, so we're going to create another loop. This loop is going to be for the C's. And if there's any B's, if we haven't reached our maximum amount of C's, so if our C's don't match our number of B's, there will be a 0 at the top of the stack, and we'll just remove it. So once all of the zeros are removed from the stack, then we know we've read in the same number of C's as B's. Now we can go to our final state. Okay. And we're not going to read in anything. Z should be on top of the stack because we read in all the zeros. So we removed all the zeros. So Z should be the only thing left on the stack. And we're just going to replace that with the Z and go to our final state. So now, let's test a string to see if this NPDA works. A. We know the string of 3 A's is accepted, but we're going to use this string. So A, B, C, C. So using an instantaneous description, we're going to show that this NPDA accepts the following string. So we're going to start off at Q sub 0. We have our entire string, and we don't have anything on the stack, so our stack star symbol is the only thing that's on the stack, so our stack is Z. Now, we're at Q sub 0. We're going to read in this first A. When you're at Q sub 0 and you're reading the A, and Z is at the top of the stack, you just replace it with the Z. Remember, we didn't do anything to the stack, but that's going to take us to Q1. So now our string is A, B, C, C. And our stack is still Z because we haven't pushed anything onto the stack yet. Now we're at Q sub 1 and we read in the A. That's going to take us to Q sub 2. Our string will now be A, B, C, C. And we haven't pushed anything onto the stack, so the stack is still Z. Now we're at Q2, and we're going to read in our last A. That's going to take us to Q sub 3. And our string is now B, C, C. And we still haven't pushed anything onto the stack. Our stack is still Z. Now we're at Q sub 3 and we want to read in the B. So that's going to take us to Q4. Q4. Now our string is going to be B, C, C. And when Z is at the top of our stack and we read in the B, we replace that with a 0Z. So now our stack is 0Z. Now, we're at Q4 and we want to read in a B. Remember, we had the loop because we don't know how many B's we will read in. So, we're going to stay at Q4 because it's a loop. And now our string is CC. And now that 0, this 0 was replaced with 2 zeros. So now our stack is 00Z. Now we're at Q4 and we want to read in a C. That's going to take us to Q5. Q5. Now we only have a C left in our string. And when you read in a C and there's a 0 at the top of the stack, I'm going to replace that with a lambda. So now our stack is 0Z. So we're at Q5, and we want to read in a C. There's a loop on Q5, so when you read in a C, you're going to be back at Q5. Now your string is empty, and now you only have Z left on the stack. Now your string is empty, there's nothing else to read in, and you're back to your stack star symbol. So that means when you get back to the stack star symbol, that just means that an equal number of C's has been read in. An equal number of C's to B's has been read in. So now we can go to our final state. We're not reading in anything, and we're not changing our stack star symbol. And so that's the instantaneous description for this following string. So we can see that this string will be accepted by this NPDA, meaning that this string is in this language. Now, I showed you all the subtuple that defines NPDA. So we're just going to draw the subtuple for this following NPDA. So we're going to have our Q, which is our state. So that's Q sub 0, Q sub 1, Q sub 2, Q sub 3, Q sub 4, Q sub 5, and Q sub 6. Now, our sigma is our input alphabet, which is A, B, and C. So, A, B, C. Now, our stack alphabet. So all the letters that we use for our stack, we use 0 and we use Z for our star symbol. Then we started at Q sub 0. Z is our stack star symbol. Now, final states. We know Q sub 3 is a final state and Q sub 6 is a final state. So, 3, Q sub